So hi everyone. So we'll start the session after 1 minute. So just wait for 1 minute more, then we'll start. Okay. So can someone confirm if my screen is visible? Just put yes in chat. So at least we come to know screen is visible. Okay. Thanks. All right. So we'll start our session. So hi everyone. Myself Pankaj, and I'll be your instructor for this SD-WAN session. So let's start, and together we'll try to understand whole SD-WAN feature, how to implement, how to design, how to troubleshoot, so each and everything during this course. So this is your day one. So today we'll just have like basic understanding about the SD-WAN, where we'll discuss about the component of the SD-WAN, how SD-WAN works, why actually we introduced, and why it is required to uh, in new network requirement, where we are just upgrading our network in the cloud environment, so that we all were going to understand what is the drawback in the legacy WAN technology, why this SD-WAN is very important, and how it is going to suppress or like give the more flexible or more feature and more advantage in terms of the software defined WAN technology. So these all things we are going to understand in today's session. And in addition of that, also we'll discuss about the roadmap, how we are going to discuss about the future classes, and what all topic we are going to cover. Okay, so let's start our session today. Meanwhile, if you guys having any question, any concern, so you guys can just use your chat window to raise your hand or just put your query in chat. So I'll keep review, and I'll try to give answer on that all queries. All right. So probably I know I have given the one of the demo session on I believe 2 week back. So might be some people from you joined, or might be not joined. So maybe some are the new, some are the old. So let's start again from the very basic. But what I'm going to discuss, I'm not going to discuss what I have discussed in last demo session. So I'm going to just discuss to the point about the core SD-WAN solution, which is Viptela is going to be used, and why we use SD-WAN. Then again, we are going to understand in this class also. Okay, so let's understand what is the first question. Whenever you are going to give any interview, or you are just going to explain the SD-WANs, people are going to ask why SD-WAN is important and why do we need SD-WAN. So this is the like key things we should need to understand. So before going to understand why do we need SD-WAN, we need to understand what is the SDN. So we have one word that is known as the SDN. So that word known as the software defined network. And in this software defined network, we having a three architecture, like three component, basically not architecture, where we having one of the WAN technologies, one of the data center technology, or one of the LAN technologies. So whenever we are going to discuss about the WAN technology in the SDN portfolio, that is known as the SD-WAN. So that is SD-WAN come in the WAN picture, where we support the WAN technology. Whenever we talk about a data center, we having the technology known as the ACI, application centric infrastructure. Whenever we discuss about the campus LAN environment, that we known as the SDXS. Okay, so these are the three components where these are the part of the SDN. So here we are going to focus about the SD-WAN, which is completely in the WAN technology, and we try to understand why it is very important nowadays. Okay, Rest these two parts are the separate module. If you guys are interested, so probably you have to do the data center, you have to go in the campus LAN, environment where you going to understand the DNAC, where we use the wireless IEs and other LAN technologies, which is like 9K switches are going to be utilized in this SDXS scenario. ACI is where you are going to use the API controller, where you are going to use the like leaf spine module, and then VXLAN going to be used as a like a protocol where they leverage and they communicate within data center environment. So these two we are not going to discuss here. Our core aim to focus about the WAN technology, that is the SD-WAN. So let us start about the SD-WAN. So when I discuss the term the SD-WAN, so earlier before the SD-WAN we having the WAN, and now after the WAN we add the like word that is known as a software defined WAN. So how it is like play key important role when you use a software defined WAN. So that basically, if we are try to discuss that SD-WAN technology, then we have to understand the WAN technology. So let's just think about WAN technology. What was happening in the WAN technology? So let's just suppose you having a one site and we having a two routers on the site, and these routers are connected to your LAN environment. So in this LAN environment, what is going to happen? So behind the LAN, your PC, your client are connected, and after that we have in the internet infrastructures, or might be the Mpls infrastructures. So could be the anything, internet link, could be the Mpls link, could be the anything. So if this is the traditional WAN technology, so what is going to happen? You just make one link as active, one link as a passive. So what that means, active and passive. So in term of the active and passive, all the traffic is keep going via the active link, and in case of the any failure is going to be happen when the primary routers, it is going to be failover on the secondary link. So this router keeps sitting in the idle situation. Yes. So what is the query? Today's class means what? Today's class, I'm not able to understand what the mean today's class. Okay. So let's just suppose like we having the R1 and R2 routers, and one router acting as a primary, another as a secondary. So in case of the any failure in term of the WAN technologies, so legacy WAN, so what is going to happen? This link goes fail, or this link goes fail for any regions, or this router goes down for any region, then the traffic is going to fail over on the secondary router. But this only come in a picture when it goes down. So the entire traffic keep going via the one link, and if the one link goes down, the traffic is going to shift another link in case of the failure. So this is the active passive scenario. In some cases you might be define the active scenario, but you have to like do some additional configuration, or it is going to add additional complexity in the your network. So majority of the cases probably you will not find this kind of solution, and you also find this kind of solution where you use one link for the internet traffic, one for the MPLS, and you just keep doing the load balancing also. But you can achieve it. But what is going to happen? Let's say suppose in this scenario, in R2 link is acting as an active router, and this is your passive router. Okay. But if this link WAN performance is going to be down, so what is going to happen? So keep this link is up and working. There is no issue in the link, but only performance is going to be down. That means there is some slowness, there is some error on the link, but link is still up. So in this scenario, this router doesn't have any intelligence to identify itself, hey, my this link having the lower performance in compared to this link, so I have to take some actions. So it is not going to do anything. So what going to happen? This user start complaining, hey, I'm facing slowness, my application is not opening due to the bandwidth is completely chalked, there is some issue on the link, there is some low reliability, the error of the link, crc on the link, could be the any region, n number of region could be. Due to that, the performance of this link is going to be down. So to avoid this kind of the situation, or to mitigate this kind of situation, it is not possible automatically this kind of the WAN technology, that legacy WAN technology is going to solve this problem. So how it is going to happen? Then it is a manual process is going to be introduced. The router is itself not able to figure out what is happening in my links, or it is not going to tell anyone. So suppose, let's say you are the L2 or L3 engineer, you are going to log into router based on the user complaints. There would be one tickets, and you are going to log into the router, and after logging to the router, you are going to start doing the troubleshooting. So once you start the troubleshooting on this router, then you come to know, hey, there is some issue in the links, and that's why the performance is going to be degraded, and that's why user is complaining. Then probably you are going to raise a case with the complaint ticket with the ISP, and further ISP is going to be validate, and they will take time to just troubleshoot and figure out where actually issue how the issue is introduced, and who is actual culprit, and then they are going to mitigate that problem, and then they will going to provide some solution. So this is going to be long, time taking process. Meanwhile, your services will be downgraded. So how basically you are going to quickly give the best user experience to this user who was facing the slowness? Then probably you use the term that is known as a failover. So you are going to do the failover from this primary to secondary. So all traffic will be the failover, could be the any region, might be you are running some HSRP in the LAN, or might be some routing protocol, IGP, OSPF, GRP, or some other protocol also that is going to be used, that also going to be do the failover. And also for WAN perspective, you are using the BGP, and also you are just going to do some manual failover kind of the stuff. Then all traffic start pointing toward this router, and it will become the active, and this will become the passive. And then all traffic start keep going via this link, and they keep talking to the internet, and meanwhile ISP will mitigate the problem, and they will fix the issue. So this is how manual processing was happening in the legacy WAN technology. But if I go with the same scenario with the SD-WAN solution, this is not going to be happen. This is not going to happen. If let's say suppose I'm in the same scenario, and this time I have the not the legacy WAN routers, I have the very intelligent WAN router, that is a software defined WAN routers. So in this scenario, I have a R1 again and R2 again here, and again I have the LAN technologies somewhere in sitting in the behind the R1, and again one PC is connected here, and here might be uh, I can take one of the internet, and one is the Mpls kind of the connection we have. Okay, so similar kind of topology, might be the internet, might be the MPLS, or could be the both, or could be the different, anything. So in this scenario, let's say suppose I'm taking both as a MPLS circuit. So in this scenario, this is router is my active, and this is my passive router. Okay, and this user traffic is keep coming from the LAN and landing to this router, and this router is further processing toward the MPLS link. But somehow, let's say suppose this link performance is going to be down or degraded for any region. Again, the CRC would be the one region, the error on the link on the another region, the reliability is going to be down, some overruns is going to be happen, utilization is going to have. There could be the any region, due to that the performance of link is going to be degraded. So this user start facing the slowness. So if this scenario was the WAN technology, then we have to introduce some kind of the manual troubleshooting by the help of the engineer, L2 or L3 engineers, who basically going to troubleshoot this issue, and based on the troubleshooting they are going to do the some failover, and there would be some kind of the configuration changes also on the router and the switches. But that was the manual. But here, if you are using the SD-WAN technology, and you having the SD-WAN feature enabled router, could be the any vendors, might be you having the Viptela one, you having the Palo Alto SD-WAN, Velo Cloud SD-WAN, Versa SD-WAN, lot of we have like SD-WAN solution in the market, any solution you are using, the end concept are remain same, might be the terminology is going to be changed. So they having the intelligence in that routers because they are software driven routers, and they having a ability to understand the behavior of the links of the circuits. So that's why they become intelligent. They having a capability to understand, hey, there is some kind of issue happening on that particular link, and if you define some kind of this action on that particular behavior, if this particular behavior is going to happen, then I have to take certain actions. Then router is automatically going to take certain action, and they automatically going to fail over that application or entire traffic to another link. So you think how life is going to be easy. In one case, when there was an issue, then you have to introduce the manual intervention, and that manual intervention is going to be, create a lot of complexity and a lot of troubleshooting configuration changes, and then your failure is going to happen. But in this scenario, you no need to do anything. The router itself or controller itself, which is software driven router controller, I'll discuss more what are the router or the controller, they are integrated together, but they having a capability to just swing the traffic based on the performance of the links, and they are going to be switch over from the one link to another link. So this is the beauty of the SD-WAN. So this is just one example I have given, so you guys having the basic understanding how the legacy WAN is differ from SD-WAN and what is the advantage of the SD-WAN. So this is just one example I have given. Now I'm going to talk about some generic things which is very important to you guys to understand. Why basically this SD-WAN is growing very fast and every company is adapting this SD-WAN is very fast. There is one reason. The reason is, you understand earlier what was happen in legacy environment when we having the normal connectivity. You having your company having one of the data center, okay, and this data center you hosting all the servers, I mean all the application you are hosting in data centers, and you having a lot of branches. So this is the branch 1, this could be the branch 2, this could be the branch 3. So you can think might be having 1,000 branch or might be the 5,000 branch across the globe. So I'm just giving taking the few branch examples, 3 4 5. So might be I have 4 branches here, okay, or another branch 5. So I have 4 branches, and they need to talk to each other and also via the data center. So how basically the solution was there? So that they having a dedicated Mpls circuit from one branch to data center. There could be the Mpls circuit. So every branch is reaching to the data center via dedicated circuit, and majority of the case could be the Mpls circuit. Okay, so these are the all Mpls circuit. It could be the internet also, but in legacy environment when we connect a data center, there are majority of the case are Mpls circuit. Some cases we use the IPSEC tunnel, IPSEC connectivity where you use the internet, so we can also use that. But that time or previous, if I talk about few year back, the internet was not so reliable. It was like no too much reliable as compared to Mpls. It was having a lot of losses, very slowness, and the services are not guaranteed. Like if you're having taken 100 Mbps circuit, they are not going to deliver 100 Mbps bandwidth throughout the 24/7. So we cannot rely on the internet. But if you taken the Mpls circuit, they are the very reliable circuit. If you having taken 100 Mbps, they will give the exact throughput of the 100 Mbps download and upload speed. Okay, but internet are very cheap, or Mpls are very costly. So it is reliable, but you have to pay more. If you are going to use the internet, they are the cheap, they are the lower cost circuits, but they don't guarantee the bandwidth. So they, if you have taken 100 Mbps, they are not going to guarantee you are going to get always 100 Mbps speed in previous cases. But nowadays internet are become very reliable, very reliable, and they are also committing very good speed. If you are taking the 100 Mbps circuit, you able to get 100 Mbps circuit. So now, why should I take the MPLS? So we'll discuss that part later, but let's understand how the things was happening in the previous cases. So every sites are going to connect the data center via the MPLS. So they are keep going to data center via the MPLS. They are keep going to data center via the MPLS, and they are just accessing the all office enterprise applications via the MPLS. And in also between these sites, we having the MPLS connection to talk to each other also. So there could be the MPLS cloud where they connected to each other also. Might be the branches also need to talk each other. So this is how the connectivity was. But let's think about that. Might be now I have a requirement to use Office 365, Dropbox, or any cloud application. Sorry, it is not working. Why? Cloud application. Okay, so I'm just giving the example. Office 365, one of the cloud application, and that might be hosted in the Azure cloud. Some cloud application might be hosted in the AWS cloud. Some could be the GCP cloud. Some could be the Alibaba cloud. Okay, so you, let's say suppose you're having a multiple cloud applications, and you hosting in different cloud services in different cloud data centers. So you think, let's say suppose you're having a 10 cloud provider, or might be 5 cloud provider, and they having multiple applications. So you need to build MPLS circuit from branches to the cloud to access the all applications. So you think, again you have to go and pay a lot of money while accessing these cloud applications. You have to pay a lot of money because you are making dedicated circuit from your branch office to the cloud application. So this was not a good idea. This is not a good idea because you are going on the cloud and you are using dedicated MPLS circuit. So this is not a good idea. You should do something by using that uh, like a special thing. You can save your cost. So how it is going to happen? So then this kind of the issue is going to be overcome by the SD-WAN solution. So what you have to do, no need to buy the MPLS circuit to connect the cloud data centers. Earlier you were connecting your data center via the MPLS circuits. That was a very high cost because you just want to get a private connection, end-to-end secure connection. So you want to get very high and reliable speed throughout your branch office to data centers. And if you are going to use the same kind of the cloud application, because nowadays every application is moving on the clouds, and if application is moving on the clouds, then you have to get very good and reliable circuit from cloud provider to your branch offices. And if that cloud provider and your branch office doesn't have the reliable and good circuits, probably you'll not able to access your all application in very scalable way or very efficient way. Might be you having a slowness, you having a latency, user experience is not going to be very good. So this kind of solution actually going to introduce very cost if you are going to use the MPLS circuit end to end. But if you are going to leverage the SD-WAN solution, it is going to save your a lot cost. How it is going to save? Let me explain about that. So in this case, you just need to replace all MPLS circuit with the internet. Because nowadays, I told nowadays all internet circuits are very reliable and loss free. They are very reliable and low loss nowadays they having available. So you just need to replace all the circuit with the internet, and you can connect all the cloud application via the internet. Why do you need MPLS? No need of MPLS. Just buy one of the internet circuit and make the reachability from your branch offices to your data center or your cloud provider. And now by using this internet circuit, you can do all the things what you were doing earlier via the MPLS. with maintaining the proper security and proper scalability or reliability of the circuit. So let's say suppose you are connecting to that cloud application via the internet, but again we cannot guarantee of any circuits would be the 100% loss free or they are 100% up. There might be the circuit could be the any problem because they are ultimately they are the technology, they are managed by the technical things, so there would be some issue circuit sometime. We having the fiber issue, some kind of the cable issue, lot of kinds of issue in circuit happening, and telco keep maintaining that performance of the circuit. So let's say suppose what is going to be happen in my branches offices, this branch 1, this branch 2, or my branch 3, they having that one of the DC connectivity, that is your on-prem DC, on-prem DC, and this is the cloud DC. Just think about the cloud DC. Let's say suppose this is the AWS DC, AWS DC. So you just have to connect this branch edge via the internet circuit. So you just connected with this all branches via the internet circuit, and what is going to happen? Let's say suppose if this branch having a two circuit, they are going to the any of the data centers. They are the DIA circuit, might be internet circuit. So if one circuit's having the lower performance in compared to another circuits, so this branch router which is sitting on this location, they are automatically going to check what is the performance of this link, and if this link having that performance is low in compared to this link, they are going to swing the traffic on this link, and they are keep utilizing the traffic via this link. So you can think in real time, no need to worry for you. Even the performance is going to degrade on the one link, they are going to switch the traffic on another link. So this is the beauty of that SD-WAN fabric. Even that link again performance is back, which is great than this link, they again swing back to the traffic on original link. So this could be the only possible when we are going to use or leverage the SD-WAN feature. If this is the legacy WAN feature, that is not possible. So this is how we can achieve auto failover. We can connect the clouds applications by using the DIA circuit without introducing the Mpls circuit. We can save a lot of cost. In addition of that, what else we can get benefit from this SD-WAN? So I discussed about the cost. One of the major factor is scalability is the major factor which was not available. Complex in operations, I just discussed, like if you are doing that, the legacy WAN technology troubleshooting failover, that is going to address additional complexity in your network. Insufficient bandwidth issues, so you are not utilizing very much your bandwidth according to your applications. So in legacy WAN, one time where your one link is going to be keep working, another is going to be keep in passive stage unless or until you are just doing some kind of the manual intervention kind of the configuration to load balancing stuff. Then if you're not doing, then it is working in an active and passive stage, and if one link going down, another link is going to take over. But in SD-WAN solution, it is not going to be happen. You can send one of the application type traffic via one link, another type of application traffic via the another link, or some kind of the routing behavior you can mold with the one link and via another link. Even the one link performance is going to be down, they are going to auto switch over to another link. So this is also very important, disjoint solution. So we not having very flexible or robust solution end to end, which is like very unique. So what that means, disjoint solution? So every location might be somewhere you are running some kind of the OSP of BGP, somewhere you're running the HSRP. You might not having very scale solutions end to end. If anything you have to run like a similar way with the one protocols, or like you have to introduce some kind of the third party vendor firewalls, like Juniper Firewall, Checkpoint Firewall, Palo Alto Firewall, or some other kind of the tools you have to introduce for the monitoring purpose. So you have to depend a lot of kind of the third party solution to achieve your goals, to scale your network, monitor your network, and do your troubleshooting. But if you're going to use the SD-WAN solution, these all feature are already available: monitoring, scalability, troubleshooting, or like auto failover, reporting. Everything is available in single box. Also, how it is possible. So this is like one of the great advantage we have in terms of the SD-WAN. Most important thing, the legacy WAN was not able to very intelligent to understand the applications, and based on the application they were not able to take certain actions, which is possible only in the SD-WAN. And SD-WAN is very scalable, and they can understand the applications behavior, and based on the applications behavior they can take the certain action. So that is also one of the feature is known as the AAR, application aware routing, in the SD-WAN, which we will discuss how it is going to work. Application aware routing. So based on the application, you can play the routing, you can change the condition of the routing behavior. So this is only possible because they understand the application, they understand the Facebook application, they understand the Google application, they understand that YouTube application, any application you can play around, and they are going to understand in the SD-WAN fabric. Fragmented security, what I discussed, like we can deploy the security on the branch side with a third party vendor, we can deploy the security on the data center, we can deploy the firewalls, all traffic is traveling to the data center, and further security is going to enforce, and then they are going to in or out toward the external domain. Or might be we can deploy the firewall on the branch side, and they can play that the same role, like while connecting the external domain. So that is the fragmented security, that is not very uniform or very kind of the inbuilt security within the box, but in SD-WAN it is available. So in SD-WAN module it is already available. No cloud app readiness. Earlier, if you having to connect that the cloud application, we having a challenges, we have to take the dedicated circuit, or might be you have to make the peering. But in SD-WAN you can directly connect that all the applications via the cloud, via the internet, so it is possible. So these are the like challenges where in legacy WAN it was not possible to achieve, or like to solve these challenges in the legacy WAN. That's why SD-WAN was introduced, and they are going to suppress all kind of these challenges and introduce the very new feature and flexible feature where they give the very scalable or very robust kind of the network information, from where you can attract or get the graphical extract and get the graphical view of what is happening in my network in real time. So till now, if anyone having any question, please ask. So just take 2-3 minute Q&A session, then we'll move for the next discussion about this SD-WAN. Any question? Yes, Pradeep, go ahead please. Yes, exactly. You are right. So in limited application awareness, in legacy WAN it was, but in SD-WAN we having the understanding of the all application, even your in-house application, any SAP application, any web application, or any internet-based application, they are going to understand, and they are going to just switch the traffic based on the configuration, how you are going to define application aware routing for that application. So that is completely possible. Yes, yes, yeah. So, apart from this, if I try to understand what are the key component of this particular SD-WAN, where we have to understand. So, before going to make that, that particular topic for the understanding, this is our labs, what we are going to use throughout the session. So, here we having the very complex and big labs. And in this, you can see that we having a different boxes. vManage, vBond, vSmart, root CA. You can see that we're having the vEdge routers connected in different sites. So this is the lab we are going to use, and they are connected with a different transport, Mpls, and the internet, and they are further connected to the our controllers, and branches are all connected to the transport, and the transport is further connected to the controllers. So this is the lab we are going to use throughout the session. So this is the dummy lab. There will be the no configuration. I'll erase if any configuration is there. So I'll erase all the configuration and I'll build this lab from very scratch. So probably let's say if today we can do some configuration if we're having a time. Else from tomorrow onward we'll just after doing that basic understanding of the SD-WAN, after understanding what is the vManage, vBond, and vSmart, and some terminology of the SD-WAN, we are just going to start and do our lab sessions. So actual things we'll going to understand during the lab session. So for the lab session also, I have built some kind of this lab guide also for you guys, so at least you know how to do the labs in the basic setup, because to bringing the controllers, it is a very complex thing. So if we try to build this vManage on board, or like make them live smart and vManage, then we have to do a lot of complex configuration, and we have to do a lot of steps. So probably you guys or anyone having a problem to memorize that all the steps. So for that we just have created that lab guides to configure how to configure these all the steps step by step. So you guys can follow these lab guides and do the configuration once I explain that all the steps. Okay, so one way I'll explain, I'll create one by one. So this lab will be fully created with you guys. No configuration will be prior configured. I'll configure and create in front of you all. So at least you understand step by step how this lab is going to build, and what the purpose of using different links, different router, and different switch, and different of firewalls. Okay. So this is going to be happen when we are going to discuss the our actual like live configuration steps. Okay. So now moving to that, the name what you have seen in here in the vManage, vBond, and vSmart, why you use and what is the vEdge routers. Okay, so in SD-WAN, if you're going to discuss in the Viptela, we having the very unique feature, that unique feature make that unique feature comes with a unique configuration and unique design of this SD-WAN fabric. So what they have, so in earlier design, we having a, let's say suppose I have a router. So this router having a three kind of the components. So you can see one of the control plane, one of the IO module, one of the switch fabric. So this component is totally inside of the routers. So this router itself is responsible to process the control plane traffic, IO module traffic, and switch fabric. So what is the switch fabric, what is IO module, what is the control plane? Let's understand this, and then we'll try to understand how it is going to be happen with the SD-WAN fabric. So you can see in this router, if any packet is going to be land on this particular router, it is going to consult. So packet having the source IP address and the destination IP address. So it is going to consult with the switch fabric, and via the switch fabric it is going to reach to the control plane, that is central processing unit, to check the routing information, how to exit particular packet which I receive. So might be this receive via this interface, or this need to be exit via this interface to connect some other network. So it is going to consult with the routing table, which is managed by the control point module, and then routing table is going to tell, hey, this is your egress interface to go out. Then probably it is going to be out. So this particular things is happening with the help of the three IO module, control plane, and switch fabric, which is inside of the closed box. But let's say suppose same process is need to be happen with the SD-WAN fabric, then how it is going to be happen? So in this case, in SD-WAN, what is going to be happen? In my SD-WAN, we have a same feature with this, what was happening the closed box in an open box. So in this open box, what is going to happen? Again, we having the IO module, you can see that. Again, we having the switch fabric. Again, we having the control point modules. So again, might be one of the PC is connected here, and they want to talk one of the destination IP address, the packet reach to the vEdge router, and then they having another interface to connect to another PC. So it is going to consult with the control plane via the switch fabric, and it is going to get the routing information, and then after the getting routing information, that is going to connect to this PC. So you can see it is going to the control plane via the switch fabric, and then it is again coming to the destination PC where they want to reach. Earlier case, it was just happening with the closed box, that was the router, but again the process was same. It was going to the IO module via the switch fabric, that is behind A6 we have, and they are connected to the control plane, and then the packet is going to be out. So this was the closed box architecture, which is the earlier we used in legacy WAN, but in this SD-WAN it is become the open architecture, where we having the switch fabric, we having the control plane module, we having the IO module, and these are the three separate entity and located three different geographical locations, not in the single place. So yes, hello. Okay, 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 all right, noted. So I was discussing IO module is basically one of the module where the edges are connected, and the switch fabric is the intermediate module where that IO module devices are connecting with the switch fabric with the control plane. So in closed box, we having the same architecture, but in the open box, we having the same architecture, but this time the switch fabric become your transport, which are the Mpls, broadband, and the internet, whatever we have, the 4G LTE. So your vEdge is connected via the internet, and they further connecting to the controllers. And then the controllers having the final decision capability for the any routing decisions. They are going to give the instructions to reach again to the switch fabric, and then switch fabric again route that particular instruction to the actual IO modules to send out the traffic. So this is how your traffic is in from this box. After in, they consulted to the switch fabric to connect the controller, and once they connect the controller, again they come back to the switch fabric and they become the out. So this is how it is going to happen, but this time they are all located in different places. So controller could be the one place, your site could be the another place, or your connecting media, that is a switch fabric, that is your ISP links. So this is how your SD-WAN architecture works. So let's understand what are the components we having in the control plane and what their roles and responsibilities. So let me just make you understand that part. So if I'm going to discuss about the control planes, so you can see in control planes overall, earlier I was discussing in this PPT, you can see we having a control planes, but in this control planes again we having a subdomains. So in subdomains you can see these are the control planes. So if I just draw one line, so this box is a control planes, you can see, and this box is the switch fabric, you can see where transport is connected, and these are the IO modules. So these are the IO modules where edge is connecting. So you can see three boxes I have. So in this control plane, you can see that we having a different boxes. So one known as the vSmart, vBond, and vManage. vEdge, just forget. vEdge always placed in the IO module, that is the data link. You can say the lower where you connect the cables to the switches or some other router or might be the PCs if you having any kind of testing environment. So controllers and control planes are reside in this particular big box, and here you can see one of the box and one of the plane is known as the orchestration plane, one of the plane is known as a management plane, one of the known as the control plane. So even in control plane we having a subdivision where one plane known as the orchestration plane, one known as the management plane, one known as the control plane. So if I talk about the control plane, that control plane is managed by that box is known as the vSmart. Okay, so vSmart actually responsible to control the routing information to entire fabric. So that's why it is a control plane. because it is going to manipulate or play with the routings. Orchestration plane basically is known as the vBond. So you can see here is a vBond. So this is the my orchestration plane. So this is my vBond is the orchestration plane. Management plane, basically it is managed or drive by the vManage. So this is my the vManage. So these all three boxes reside in the control plane. Overall we can say controllers. So these are all three are the controllers, but every controllers again having the unique features. One for the orchestration plane, they are keep doing the orchestration for the network. What that mean, I'll explain later. One for the management plane and one for the control plane, so that this manage for the all routing. So at least you should know the three component name: vManage, vSmart, vBond. These are the controllers and they reside in the control plane. Okay. Now last we having the vEdge, or we having another router that is known as the cEdge. So we having a two routers name in the Cisco SD-WAN that is known as the vEdge and cEdge. They basically reside in here, that is the data plane. So these router you can see here, these all router could be the vEdge and could be the cEdge. So this basically known as the IO module, and these routers basically actual connecting to the site location or your data center to connect your LAN segment. So this is how your cEdge or vEdge going to be deployed. And in between we having the Mpls circuits or internet circuit, they connecting to the upper box and the lower box via this circuits that is known as the switch fabric. Okay, Pradeep, you having any question, please ask. Pradeep? No possible. Only these are vendor specific, Cisco specific. Okay, Viptela is acquired by the Cisco, yeah. So Cisco box ISR, ESR is already part of the Cisco. So other vendor is not going to support. Okay, all right. So I can see two other people. Yeah, Vishnu, please ask your question. Your voice is very low. Uh, yes, exactly right. Uh, mm. The best practice, these controllers would be your on premises or could be the cloud deployment. So it's up to you how you are going to decide to deploy these controllers. Yeah, please. What do you means vendor based? Like Cisco can. Okay, okay. Uh-huh. No, what I can say, your on premises is going to be more costly than cloud nowadays. If you're going to deploy, where cloud is nowadays very cheap, so you just have to take a space and you have to just deploy the image. What I have just deploy here, and they are just going to make the reachability. So it is not going to overhead your the operational cost, your hardware cost, your electricity cost, cooling cost. They are all maintained by the vendors. Okay. Uh, Yes, definitely. If you're having that cloud-based solution, the cloud vendor is also responsible equally like you. If anything is going to happen, they are going to help out at least in terms of the making your infra up and running as a 24/7 live. So then rest troubleshooting you can do with by your vendors like Cisco tech support or by your own, whatever you want. but no need to worry about the infra. Yes, whatever I have seen, these controllers are basically 99% I have seen they are on the cloud-based solutions, not from the on-prem, because it's not uh, good or wise decision to deploy the controller in the cloud-based. You just have to take that, subscription from Cisco or any cloud provider. You can deploy this controller in the clouds. Yeah, yeah, welcome. So this is how we having a different planes, and every planes they are having their own responsibility, and that having their own boxes mapping on that plane. So orchestration plane is responsible for the vBond, management plane for, responsible by the vManage, and the control plane is managed by that the vSmart. So we'll discuss in depth about the functionality in the upcoming slides. And we understand about the vEdge and cEdge, that are the part of the data plane where they acting as the IO modules to connect your actual LAN infrastructure. And in between we having the switch fabric, they are connecting to the controller and the data planes. So this is how we having the secure extensible Viptela network design into the control plane, orchestration plane, or management plane, and the switch fabric and the data plane. So hope it is clear to everyone. Now moving to that next slide about that functionality of that vBond and vManage and vSmart. So let me just move to this slide a little bit the same having a concept. So here we understand these things. Now we understand one by one what is the orchestration plane, that is the vBond. So let's understand what is the orchestration plane and how this orchestration plane is very play important role in SD-WAN fabric. So before going to explain in this what is written in this slide, let me just give an example. So in SD-WAN fabric, it work in zero trust model. That means what that zero trust model, like I'm not going to trust you. Whenever you come to me, I'm not going to trust you, you are right person or authorized person not. It is only going to be trust if you prove me with a valid identity you are the right person, and if that identity is going to be verified by my fabric or my respective controllers, then only I'm going to allow inside of my fabric. So this is how this fabric is going to work. So zero trust model, it is not going to trust to anyone. Might be we can see somewhere it is clearly mentioned zero trust, or I'll show you later, no worry. So it is going to work as a zero trust model where they are not going to trust to anyone. Simply if you are coming, then you can see here zero trust fabric. So here zero trust, we having another term zero touch, that is completely different from the zero trust. So we'll discuss later why is zero touch versus zero trust. So we are right now we are talking about the zero trust. So zero trust, that means nobody is going to allow to enter in my fabric. If I talking about the fabric, that is the collection of the SD-WAN devices, they are interconnected to each other and they are doing some kind of communication, they become one fabric. So if you are going to introduce any devices in that existing fabric of the SD-WAN, so nobody is going to trust you unless or until you are going to prove yourself you are the authorized person and you are designated to enter my network. So this is how zero trust fabric come in picture. So who is going to validate that anything which is going to come in your network? So who can come your network? So let's say suppose you having the very good SD-WAN. This lab I am going to take in. Okay, so this having the vManage. Let me just use the this having the vManage, this having the vBond, vSmart, vEdge routers. Okay, and these sites are already part of the SD-WAN fabric. But let's say suppose tomorrow again I have to add one more vSmart here, or might be again I have to add another vEdge router here to connect the fabric. So two devices I wanted to introduce. So these are the legacy devices already in part of the fabric. They are already proven their identity and they are joined to the fabric. But these two are the new boxes, and these vEdge is also new. So they have to have proof their identity. Hey boss, I am the right person. Please allow me to join the fabric. So who is going to verify the credential? Even could be the vBond. New vBond is going to be introduced. New vManage is going to any box. Could be the any box. vBond, vSmart, vManage, or vEdge or cEdge. This is the 5 type of boxes are compatible with the SD-WAN fabric. If any of the 5 type of boxes is going to be join the fabric, they have to prove their identity. So how the identity is going to be checked and who is going to be responsible to check that identity? Let's discuss about that. So let's say suppose you get a offer letter from any of the organization, and let's say you're having a joining from the Monday. So what you have to do? So once you visit your office by the Monday with your offer letter or other credential, whatever you have like Aadhaar card, PAN card, passport, or some photographs, whatever you have, or other documentation, certification, and all. So once you enter to the office, someone will come from the onboarding team or HR team. They will come on the reception, and very first place at the reception, they are going to verify your documentations, or might be in somewhere in the reception we having a meeting room. So they are going to verify your identity. You are the right person who having the correct offer letter or right identity. And if you are able to prove that you are the right person, then only they are allowed to enter inside of the organization where your joining is going to be happen in secure meeting room, or might be some HR meeting room. So then you are going to enter in the offices. So similar way that onboarding and HR person are responsible to do their job. So similar way in my SD-WAN fabric, my vBond is acting as a HR. So that is onboarding person. So this is the similar responsibility they hold. So any devices, let's say suppose I'm the vBond and any vManage want to join my fabric. Let's suppose a new vManage, or like very first time they are going to join, any cEdge going to join, any vEdge going to join, even any new vBond is going to join, any vSmart is going to join. They are going to verify and check the identity of that all boxes or all new devices which is coming to the SD-WAN fabric. So they play as a role as the onboarding or like HR onboarding team. They just verify the credentials, that credential known as the certificate in that SD-WAN fabric. So they having the provision to exchange their certificates while communicating to one box to another box, and that certificate is going to be verified. And if that verification is going to be success, then only vBond is going to allow to join that particular device to the SD-WAN fabric. So this is the first role and very key important role is going to play. So that's why we known as orchestration plane and the management plane also, because they are going to do orchestrations of that particular our whatever the communication is going to happen via the new devices before joining the fabric. And first point of the authentication, that is the same thing, whitelist model what I am talking. So this is going to be authenticate, you check the credential, verify the credential, then it is going to establish the connection, and then everything is going to verify. They are going to distribute that the device list, the vSmart and vManage, whatever the devices are just joined to your fabric. So let's suppose any device join, then after verification of that credential, they are going to distribute the information to that the other vSmart and vManage devices. In addition of that, they play additional role for the Nat transferable. So Nat translation, they play a role. Let's say suppose you having the Nat requirement, you having the connectivity over the internet, and you have to do the Nat private to public. So someone is just hold the Nat translation information. So this basically also done by that vBond orchestration. So NAT role is also maintained by that. All NAT translation and not NAT entry is maintained by the vBond orchestrations. So this is how vBond is very important and highly resilience. We can make it by creating the two vBond. So in our topology, just we having the one controllers because they are the very high memory and the CPU utilization they are required. So we cannot make a lot of vBond and vManage, but if we're having to use the high resiliency environment, you want to make one vBond, if goes down, then another vBond take the role, then you can also do that. So this vBond play a very key role in terms of the any new devices is going to onboard. They need to authenticate, manage the things. They have to check the identity, do the Nat translation, information mapping. They keep and keeping the record in vBond, and they distribute whatever the devices they just landed to them after verification to vManage and vSmart. So this is how vBond is. Now the next element we have, that is the management plane that we were discussing about, that this device uh, vManage. So this vManage is known as the management plane devices. And so in this vManage management plane devices, this is the like one of the powerful tool. They basically do that single pane of glass. While sitting on this, you can do each and everything about your fabric. So what all things you can do by sitting on this particular uh, SD-WAN fabric. So basically once you start doing that, any configurations, that all configuration is doing by that vManage. Any kind of the monitoring, so configuration you can do, any kind of the monitoring you can do, any kind of the policy you can create. So you can see policy template, troubleshooting, monitoring, software upgrade. So up if you're having that any kind of software upgradation requirement for the any vEdge or CS devices, you can do that software upgradation by sitting on this vManage. So I will show you how it is going to happen and right away after understanding the theoretical stuff. So we'll bring that one of the vManage up and walking, and also how it is going to be happen. So then policies and templates, centralized provisioning, multi-tenant, so everything rest if you're having any kind of the connectivity of their third party API, so rest conf and net conf, you can use that, as a connectivity for the REST API to just understand and interpret with vManage whatever the things are running inside of the vManage. You can just integrate and get the output, and you can just manage and you can play with the statics of the vManage. So that all things is going to be happen. GUI with rollbacks, or like you just role based access you want to define, you can just do with the vManage. If you want to give someone L3 role, L2 role, L1 role, you can just make that all provisions for the all users via that vManage. So this is how you can play a very all kind of the configuration management, centralized provisioning, policy, template, monitoring, configuration, everything you can do via the vManage. So this is the one of the most powerful tool where we can play each and everything 90% things from this tool. So only few things we are going to play around the other devices, but 90% things we are going to play around the vManage, because this is the tool from where we can do each and everything, configuration, troubleshooting, monitoring, policing, everything we can do that. So after this vManage, we have a next item that is known as the control plane controller, that is the vSmart. So this is the very important role play in this fabric, because they just maintain all routing informations. So in routing in this SD-WAN fabric, they use that routing protocol that is known as the OMP. So overlay management protocol. So every sites, they run the OMP protocols from that vEdge to that particular vSmart, and they keep changing the routing information. So in this topology, if you see that this vSmart having that different connectivity with a different transport, so they just maintain that OMP sessions via this one internet link, via the one Mpls link. So they build the OMP sessions, and via the OMP session they just keep exchanging the routing information from the vSmart to the vEdge routers. So all location, with the help of the different transport, they keep exchanging their information via that particular what I can say, the transport. So the OMP session is going to play a role in terms of the routing information exchange between the site and between the controllers. So and then after that, this OMP control plane like also help to just very important role they are going to play, whatever that we having that policies, whatever we're going to implement for any kind of the policy. We having a lot of types of policy: centralized policy, localized policy, so app aware routing policy, hub and spoke policy. So a lot of policies we have, we are going to discuss. We understand all the policies. So all the policies whatever we're going to create, they are going to push to the controller. So we create the policy on the vManage, they are going to push to the vSmart, and then vSmart is going to apply to the vEdge routers. So this is also one of the key important role to just distribute and play the you know policy to the devices. So the key things, the policy information and routing information, application aware routing and the plane routing, whatever routing we have, they just done by the control planes. So we can just think about this, the controller is very important in terms of the controlling the entire fabric in terms of the routing, application aware or the policy. So this is how the control plane is the also very important key roles. So now we understand all three controllers, where we understand the vManage, vBond and the vSmart. So controllers functionality we understand. Now we have to understand our edge routers. So what that means, the edge routers could be the cEdge and could be the vEdge routers. So first thing, these routers are reside on the every sites, that could be the branch site or data center or campus, any kind of sites we can deploy this kind of the routers. And once we deploy this kind of routers, we need to connect our WAN connection and the LAN connection, and they provide the secure data plane with the remote edge routers. So they having the very secure features and secure data connections to connect your LANs, and from that LANs basically you just play around uh, with a very secure communication with your SD-WAN fabric. And also they establish very secure OMP control connections over the DTLS and TLS tunnel with the vSmarts. So that is also because without uh, establishing the OMP session over the TLS and DTLS connections, the routing information is not going to be changed. So this is also uh, we can leverage that OMP feature, and we can build the routing information from that router to that particular our vSmart devices to exchange our routing information. Implement the data plane and the application of a routing policy, export the performance as statistics. So like if you having the data plane, application of a routing you want to implement, that is going to be apply on that cloud routers. I'll show you how it is going to be applied, this policy and application routings on the routers. When we'll discuss the localized policy and centralized policy, we'll discuss these things in very detail, so you guys going to understand and correlate what that mean. And that this is the statistics they are talking about, the any performance related statistics they we want to export from the router, we can export it. That is completely possible. I'll show you how it is going to be happen. They also support the traditional routing protocol like OSPF, BGP, VRRP. So this is also possible if you are running that these all routing protocols in your legacy environment, they are going to be support of these vEdge routers. And the last thing, very important thing, they also support zero touch deployment. So earlier I talked about the zero trust deployment. Now let's understand zero touch deployment. So what is a zero touch deployment? So let's say suppose in previous cases, what is going to happen? Any router is going to be down. So you have to arrange a technicians, field engineer to go on the site and install the rack, install the router in the rack, and after installing the rack, router in the rack, they connect the WAN cables, they connect the LAN cables and WAN cables, they connect the power cables, and they do the power on of the router. And after power doing the power on, they have also shared the console to that the NOC engineer or like whatever the concerned engineer, they are going to troubleshoot or configure that router. And then basically the router is going to be configured by remotely via the NOC engineer, and they just take the old configuration and configure that the routers. So you can think like how the complexity is going to happen. One place your router is going to be reach on the site, and then you have to take the remote access, then you have to import the old configurations, and then you have to again check and do the testing and all. But what if I just install the router and connect the WAN cable and LAN cable and power on, and my router is automatically come in service? Is it possible? Yes, it is possible in SD-WAN fabric. No need to do any configuration by the taking the remote of the router. And that process is basically known as zero touch deployment, which we'll discuss in very detail how it is going to be happen, what is a zero touch and how it is going to happen. So when I explain my zero touch uh, ZTP process, then we'll understand they having a certain steps we have to follow, and by following that steps we can achieve that zero touch provisioning. So once we do the power on, what and how the process is going to be follow, what all several step is going to be happen, and how zero touch process is going to be achieved. So we'll discuss someday in later upcoming classes about this feature. So for now, you just understand this is the unique feature we having in this SD-WAN that was not available in the earlier sessions, like earlier legacy environment, and now we can do this particular zero touch deployment. Also, this router could be the physical and virtual. So right now, if you want to buy the physical hardware, you can buy from the vendors. And if you don't want to buy, you want to just deploy like virtual. What I deploy, these are the virtual all router I deploy in the EVNG platform. So even I can deploy this also. So this is how my vEdge or cEdge can be deployed, and this is how we can implement the zero touch provisioning, run the OMP and the routing, whatever the legacy routing, we can support it. So anyone having any question about these controllers and vManage and the vBond? So let's have discussion 10 minutes, then we can continue our session. Yeah. Yes, and just give me 1 minute. So orchestration meaning is like something you just think about automations. So orchestration automations, you just think in this way. And anything if I'm coming to you and I want to orchestrate, so I want to automatically verify your credentials. I want to verify your credentials. So that is going to automatically checks via the software integrated with me, and based on the whatever the information you have, I'm going to verify with my database. And after verifying with my database, I'll just confirm you are the authorized to join my fabric. So this is like, you just think the HR onboarding, they having the full authority to check any credential of candidate coming to the office. The same way vBond is like orchestration or validation plane, you can say. They are going to validate the data, whatever you have, certificate, whatever you have. So these are the like one kind of the, you can think in this way, orchestrate that all information whatever you have, and based on that orchestration they are going to verify and they are going to check and they are going to allow. So facilitate, yeah, like Nat translation is one of the like uh, yeah, that is same thing. Yeah, that is same thing. Any question? Yes. vCenter. vCenter is one of the Cisco, I believe, server, I believe, where we can deploy the multiple applications. So that is not part of the SD-WAN solution. Okay. Anything else? Okay, so let's discuss something new. Just give me 1 minute. Let me just stop this here.